Hi, everyone. This is Tom Broussard. This is another article in that series about the science and scientist who had one hand or another, as it were, of the brain with stroke, aphasia, and plasticity. In this case, the new scientist is Marian Cleeves Diamond. She is a wonderful scientist, started this in the 40s, like so many of the people that we've been talking about. Um, but not unlike most of these scientists, most of them are passed in the 1800s and early 1900s. Um, we mentioned before, I have been in contact with two other scientists, um, and Martha Sarno is one. Had an interview with her last month, sorry, and another one up in Canada, who is also still alive. So I've been working on this for many, many years, long before I would start to write this series. And several years ago, obviously in the 2015, 16, 17. And in 17, I was studying Marian and her book, Enriched, Enriched the heritage. And she was just incredibly good at what she did, and obviously worked with mice and rats, studying the brain and hoping that eventually she'd be able to translate that um, um, understanding into how the brain works. Because believe it or not, of course, the mouse and the brain have very, very similar characteristics of the brain. So in 2017, I was studying her, reading her stuff, saw that she was still alive and working at USC Berkeley, and sent her an email in early summer of 2017. I didn't get a response yet, but with all these scientists, I always go to them one way or another, keep finding new emails, sending them more emails to different places within their world. And sent the first one in June, another in July. And then I got sick with, you might remember, TAVR, a transcatheter aortic valve replacement, to replace an already replaced aortic valve that I had with open heart surgery in 2011. So it's just been 6 years since I lost that valve. The replaced valve had to be replaced again. And I was in the hospital for 13 days, so obviously a long time. But as I get better, I emailed Marian again in August, actually August 25th, I think. Still didn't get a response, but thought, well, I'll continue to look at the obits just to see if, in fact, some of my scientists might have passed while I was in the process of researching their lives. So I did look on in California, UC Berkeley, and found out that she did pass on July July 25th, 2017. For me, it was quite a shock because that was the day of my TAVR. So that was a Monday. And I was seriously in trouble when that happened. And it wasn't obviously until months later when I discovered, or a month later, I discovered she had passed on my birthday, on my TAVR birthday. So anyway, thank you very much to Marilyn for doing the work she has done over the years, and glad that I came close enough to understand who she was in life as well. And she was 90 at the time. Anyway, she got her bachelor's degree at UC Berkeley in 1948. Obviously, like so many of the scientists, they end up doing any number of things to make their way into the PhD world, because it typically does take good 20 years, because you can make your way all the way through and become an accredited research PhD. So in her case, that's exactly what she did. She got her PhD when she was 1953, became an assistant professor, then associate professor, then a full professor at UC Berkeley, and stayed there the entire time. Eventually become a professor emeritus, basically the best, and the passing beyond retiring. And she continued to teach until well into her 80s. So if you look on her website, you'll see all kinds of things, videos about her and what she loved the brain. So after 60 years of research trying to figure out, using other animals, typically with rats, to help us humans understand how the brain works using that kind of experience. But and again, many of these scientists have done so many other things too, sometimes close by, but sometimes completely different. In her case, they were relatively close by, because around that time in the 40s and 50s, everybody knew Einstein, and Einstein died when he was 55, 1955. And all of the scientists hoped that somebody had saved his brain because he was so smart, given his theory, that everybody wanted to get a hand on that and get to see what his brain looked like. And eventually, Diamond ended up getting 4 thin slices of Einstein's brain. And of course, it wasn't until 30 years later when she got it. So obviously, this person, you get to see it in the article, this guy who actually was the person who did the autopsy, actually took his brain out and saved it and didn't tell anybody, didn't tell his family that he had saved the brain, and he kept it, and preserved it. And like I say, 30 years later, because it took a long time before he could start to distribute it, and he didn't want that to get into the wrong hands. So 30 years later, Diamond got 4 slices. Many other scientists around the world actually got some of those tiny slices, but everybody could use that, probably based on their own understanding and theory that they had about one thing or another. So in Diamond's case, she led that team at UC Berkeley, studying Einstein's brain, understanding more about the glia cells. We'll talk about that later too. And she ended up writing a paper and a video about the brain of Einstein. But and what she did find out was, of course, that the glia cells. So we have neurons. That's the thinking, what they call the thinking cells. And then there's even more. There's 100 billion neurons. There are more than that. There are glia cells that do all kinds of work, and they're right next to the neurons, and they physically support it, and do lots of other activities that they do. And believe it or not, the glia cells in Latin are glue. So clearly they glued it all together, holding it all together. And they meaning Diamond got to understand that she was basically studying both the neurons, neurological cells, as well as the non-neurological cells, which are the glia cells, and began to realize that there were more glia cells in Einstein, more than normal human. So, and then really just started a conversation over of how the glia cells actually work within the body. Along the way, she started moving into working with the rats, and did a huge sets of studies, understanding about what she now came to understand. That's why she read the book Enriched Heredity, about enriched environment and plasticity. Again, this is years ago for me when I discovered who she was, discovered about this issue of enriched environment versus impoverished environment, and using the rats as their environment being either enriched, which meant there were lots of rats within a cage, lots of food, lots of water, lots of fun toys for the rats to work with, and there were impoverished rats, some of them all by themselves in a cage with nothing more than the minimum amount of food and water, sometimes with a couple of rats all by themselves in a cage, but no additional toys and activities. obviously cognitive activities, to the degree they're cognitive activities, um, and then studying how, as a result of creating that, then whether those rats were able to do certain memory type things, including the maze. And sure enough, the impoverished rats couldn't make their way through the maze. It took longer to find their food, if at all, whereas the enriched environment and the enriched, what they call the enriched rats, could find their food, could find it quickly, and began to understand that memory and the difference between the two, because one had more ability to grow more dendrites and synapses, as it were, inducing plasticity and inducing more neuro matter, which is exactly what happens when you have a person with stroke and aphasia, because you will have typically lost several 100 million neurons, and with it go the associated dendrites and synapses. And you have to grow new dendrites and synapses. And with the rats, she came to understand that by giving these rats a much more enriched environment, as it were, an enriched society, the rats could grow new dendrites and synapses, and were able to do what they couldn't do before, including unfortunately, creating strokes for those rats, right? Like you and me having a stroke, and in my case, aphasia, but actually creating the stroke, losing a certain amount of information that they used to have, an ability, and now able to do it again based on being placed inside of that enriched environment. So this is all part of her understanding that those structural components of the brain had in fact changed as a result of being put into that environment. And you can only imagine, if you take the same rat and put that same rat into an impoverished environment, the same thing will happen in the opposite direction. So you could actually move them from one to the other. And it took time. Sometimes they had these rats for 3 years at a time, typically measured in days. So at 900 days, 950 days, you can only imagine if you had them here and they were now impoverished, move them over here, they grow, right? If they're already here, move them over here, they diminish. Their brain loses the dendrites and synapses, basically losing parts of their learning field, as we have our learning field when it comes to the synapses associated with the dendrites. So it is very, very interesting, as she came to understand that the enriched environment was all about an environment that was novel, that was a surprise. A rat sees something new to eat, they get sort of excited. We get the same thing. Well, sometimes cheese, sometimes other things, but novel, repetitive, intensive activities, again, all associated with the 10 principles of neuroplasticity. So she understood that, wrote about that, and let us much better understand why the enriched environment is how plasticity works better. And that happens with humans. It happens in elementary school. It happens prior to that. And then even as humans, we use the word impoverished because we might be living in a cold, no water flat with crime and other kinds of social economic issues. And as a result, those kids may be highly impoverished, not have enough food, and can't get it any other way, as opposed to an enriched environment. So that turns out to be highly, highly helpful when it comes to how humans learn. And also for people who have stroke and aphasia, given that 30 to 40% of people, in addition to other physical issues with stroke, also have aphasia. And in all cases, and I don't want to say in all cases, but in most cases, always depending on where the stroke is in the brain, how long it's been there. There's all kinds of those kinds of factors, where they are, how long you've been without blood. But for all of that, the brain has that capacity to grow new additional neuromatter. Cortex does actually grow. You can measure that, and develop more dendrites and synapses, adding to the learning field that were lost when you lost those cells. And as Diamond said at the end, she does believe that teaching students and the wider public about how the brain and plasticity work, that we must be taught that from elementary school, from the beginning of life. And it's not unlike photosynthesis, where it converts light into green leaves. Plasticity converts thought and cognitive activities into new brain matter. All those activities, you might as well think of them as light. That is how it works. You don't have to know a whole lot about it, but you have to know that it exists, and it is useful if you come to understand, if I do these things in more of an enriched environment, you will grow new things, learn new things, understand more things if you live in that environment or put yourself in that environment than an impoverished environment going forward. And she insists that we start doing that from the beginning. I will read it here. I'll read this last paragraph that I put here from the article. We have begun to appreciate the plasticity of our cerebral cortex, the seat of the intellectual functioning that distinguishes us as human beings. We must learn to use this knowledge. It must stimulate and guide our efforts to work toward enriched environment heredity through enriching the environment for everyone at any age, including recovery from people with stroke and aphasia. So she was quite a scientist and quite a person in the modern world, and helped us better understand, using rats for all those years, how it works for us with stroke and aphasia, and do get better based on plasticity. And that means plasticity occurs more rather than less in an enriched environment. Another star. She is number 20. There are 4 more articles coming up. They will come up in the next month before the end of the year. So yes, it'll be quite quick, because every week for December we'll have a new article, a new video about 4 more to get to the end of the 24 articles. So looking forward to that, looking forward to the holiday season, and looking forward to starting next year's series, although I probably won't start that for a month or 2 as I sort of rest and get ready to start the next challenge with Plasticity Inc. Nice to see everyone. See you again in another 10 days or so. Take care of yourselves. Bye-bye.